let's dive into this is access network capacity and reliability. So really looking at some of the technologies, because a lot of people feel that with your access network, it's no longer viable, right? So our access network, again, is the network from your central organizations or your head ends, your data centers, your hub sites, but it's really how you provide the signals to your customers. And at one time, it was all coax, right? It was all coax. What did we do with that all coax network? Anybody remember what we did with it? We upgraded it, right? So over the years, we upgraded it from an all coax network to a little bit of fiber optics and a little bit of coax. But did we replace it? No. Why not? Very costly. Construction is very, very expensive. We have several fiber to the home projects in the United States that just stopped. After spending $20 billion, Verizon just said, whoa, I got to stop this. I'm bleeding money. And concentrate, what they want to do is concentrate on the dense areas. Yeah, it's great to build out a brand new network in Kingston where there's dense populations, but you'll find that doing that across the entire island could be challenging. So what I want to really focus on here is how do I leverage my infrastructure that I have today without replacing it. So the reason we added fiber to the network was to improve its reliability. That's why we did that. And you think about, we keep hearing passive optical network, fiber to the home, we're going to build out fiber all the way to the customer. You don't have to do that to provide reliability. And the largest operators aren't doing that. They're saying, well, I'm not going to do that. I'm not going to build fiber to every home. It does not make sense when I got the infrastructure. So how do we get there? So this is kind of the landscape is changing slide. And there's a lot going on here. But what we're trying to do is we talked about network reliability, right? And how do we guarantee that? It's called a service level agreement. We are trying to make our networks more reliable. That is a fact, right? And what we're doing now is going after small business customers. We've been doing small business customers, but really going after small businesses for the internet infrastructure, providing video service and voice services, hosted PBX, public branch exchange for voice, those type of activities. Well, in order to do that, we had to make our networks more reliable. That means they have to operate, when we started, they operated 90% always on. So 90% of the time, the network was up. You say, well, we got to get there, Steve. Or we might already be there. Today, 99.9% of the time, the network is up. 99.9. Where we want to get to is 99.999% of the time. So less than 10 minutes per year. That's where our data center core network head end, that's where that should be. But it's steps. Okay, if I'm at 80% today, how do I make the network more reliable and get to 90? How do I get from 90 to 95? How do I get from 95 to 99? And 99 to 99.9. So we got to constantly take a look at the network. And I'll talk about proactive network maintenance that allowed us to do that. We know we need better Wi-Fi. Talked about that. Ongoing challenge has always been the upstream. We are now addressing that. So you're going to have to address your upstream in the future. We don't have enough upstream, and that's been a challenge because think about how people use our services. They are producing content now. Back in the day, we were receiving content. Today, we are producing content, and you need the upstream. So you have to have a plan on how do I increase my upstream. And that's called mid-split. We'll take a look at that. We talked about analog to digital simulcast, which is basically converting to digital, and that's helped us. But I talked about MPEG-2 reclamation. How do I get to MPEG-4? Because MPEG-4, you could do a 100-to-1 compression ratio versus a 40-to-1 compression ratio. And 200-to-1 if you go to HEVC, high efficiency video codec. So you have to have a plan, evolution, how do I take my video to the next level to free up bandwidth, right? Because if you don't have the bandwidth free from the video, how do you improve the internet? So the new way internet works with DOCSIS is you use channels. So before we used to run internet over one channel, 6 megahertz or 8 megahertz, depending on your location. Now we combine the channels together. Today, we use 192 megahertz channels in DOCSIS 3.1. That's where we are today. Big operators. Little operators are still at DOCSIS 3.0. And in order to do that, you need to have the space to do that. Over the top, so we know this is a growth, there's no question about it. But what we're doing now, we're taking the over the top and putting it through our cable modem termination system. We're combining the video and data networks together. So how do we get to a convergence of these services? We know we already have convergence of voice and data through the cable modem termination system. How do we get video in there as well? And now we're talking about symmetrical DOCSIS, which is the next version. That means that the downstream and upstream are the same speed. So 500 megahertz downstream, 500 megahertz upstream. So if you take all your video and you put it through your cable modem termination system, you don't need video anymore on the HFC. It all runs through the data. And now you can do 500 up and 500 down. And that's megahertz. And if you take two 192 megahertz channels, that gives you 10 gigabits per second over an HFC. Now we're not talking an HFC with 10 amplifiers deep. Now we're talking an HFC node plus 0, node plus 1, node plus 2. And then we're talking 10 gigs. So as you think about that, how far do you want to go? Well, I just want to get to 500 megahertz. I just want to get to 200 megahertz. It's those steps. But that's the kind of thinking of where the landscape is changing. Now here's DOCSIS. There's different flavors. If you're still using DOCSIS 1.x, that's okay. DOCSIS 1.x and 2.0 gave us the ability for voice over IP services. It also improved the modulation and multiplexing in the network, which gave us enhancements. But we should really be thinking of having DOCSIS 3.0 in the network. And many of the smaller operators that I've kind of talked to in this area in South America, they have DOCSIS 3.0. I'll give you a story. Suddenlink is a medium-sized, maybe considered small operator for the United States. And they just got purchased by Altice out of France. And at the time, Suddenlink said, we're not going to deploy DOCSIS 3.1. We are going to take DOCSIS 3.0 to 1 gig. And they did. But it was 32 channels they needed. So they actually reduced some of the video, moved it to more streaming through the CMTS, and they offered a 1 gig service over DOCSIS 3.0. So they didn't have to buy or purchase 3.1. So just want to, even though there's the latest and greatest new shiny apple out there, you don't always have to go out and grab that. The nice thing about DOCSIS 3.0, it supports, like I said, 32 channels, so you could do 1 gig, but it also supports 8 channels in the upstream, so you can actually increase the upstream capacity to your customers with the same technology. And most of the small operators, actually, I would probably 70% have DOCSIS 3.0 in their network. They've invested in that because they feel that that internet is the most important to them. They might not be able to sign all the different content deals that they want, but they can provide good quality internet, which allows them to go after business services. It allows the customers to have good quality internet in their network. Now the 3.1 future, gigabit, new multiplexing. The only thing I'll say about the new technology is you can run both of these at the same time. So you don't have to upgrade your entire infrastructure to run the new version of DOCSIS. You can run both together. So if you want to run DOCSIS 3.0 and run DOCSIS 3.1 over the same frequencies, you can do that. And you can do it in pockets. So perhaps I want to do that in Kingston, or perhaps I want to do that in a dense populated area. That's the nice thing about it. And another thing, you don't have to start off with big channels. You can start off with smaller channels like 24 megahertz. You don't have to go to 192 megahertz channels. So it's designed to be incremental. DOCSIS, the whole, Cable Labs is our partner. It's the engineering arm of the cable industry. That's SETE. We're the standards in education and cable show. Cable Labs is the engineering arm. They develop the specifications. We turn it into standards and training. That's what we do. But it's all designed to be incremental. So you don't have to deploy everything at once. I could tell you that DOCSIS 3.1 upstream does not exist yet in the US. Because it's an incremental approach. You do not have to have it. So it's on the roadmap. And the future is where upstream and downstream are the same. So that's what 192 megahertz channels look like. And if you look at the technology, everybody gets scared about the technology. This is orthogonal frequency division multiplexing. You're like, whoa, what's that? It's the same technology that Wi-Fi uses in your home. So if you're using a newer version of Wi-Fi, it's the same technology. And that's why I said training is so important, because if you really understand the technology you're deploying today, this is not a big deal, because we already do this in Wi-Fi. In MoCA, we already do this. But this is what it looks like. And really the key point here is it's a bunch of sub-frequencies into one big frequency. That's how they achieve it. So you could do 7,800 sub-frequencies in 192 megahertz. And if you knock out 10% of them, the signal still works. Knock out half, the signal still works. It's able to adapt. It's adaptive. You probably heard of adaptive streaming, when the quality goes down because of your network. Same thing. This is adaptive too. Oh, all of a sudden the network's noisy because we have a loose fitting on the amplifier. DOCSIS 3.1 still works. So that's the design. This is the upstream, expanding the upstream. Right now, most of us have an upstream from the customer to the cable operator about 42 megahertz. And typically, we don't run high orders of modulation below 20 megahertz. It's just because it's very noisy in our network. And we typically like to have our data sit between like 20 and 36 megahertz. And you're like, well, I really don't have any room to do anything else. But you're able to change the technology. The upstream channels, when I started, were 1.6 megahertz wide. Today, they're 6.4 and channel bonded. That means they go to 12.8, and then you can double that and double that. But the nice thing is you could still use 1.6 megahertz channels. But this is what your network could look like. And what was interesting is talking to folks, Cable Onda in Panama, this is something they're striving for. They're like, well, we're going to work towards getting our networks out to 85 megahertz. This is actually doable with the noise floor very similar to 42 megahertz. So depending on, these are just what's available to you. These are toolkits. Say, all right, well, you know what? I really like the idea of DOCSIS 3.0, 3.1. I'll worry about that in 5 years. Now, the big thing here for reliability, I keep hearing reliability and quality. That's what we want in our network, whether it's through the installation, whether it's through the network itself. There's been a technology developed called proactive network maintenance. What if you could have a technology in your network that could tell you when things are going bad? And you could actually fix it proactively before the customer even knows. Proactive network maintenance. This is the technology that's available in DOCSIS 3.0. So it's another reason where, okay, maybe we need to upgrade to DOCSIS 3.0. We need to take it from 2.0 to 3.0. What this allows you to do is that every cable modem that's in a customer's home is a sensor. And it reports back to the cable operator and will tell you where things are going bad in the network. The technology has evolved over the last 5 years to we can pinpoint problems in the network to within 10 feet. So tech gets out of the car, oh, right there, loose connector. Fixes it, gets back in the car. So think about efficiency, troubleshooting efficiency, customer reliability, customers are happier, you're able to diagnose problems faster in the network. This is great. And it's something to kind of think about. How do I, if I'm looking to improve quality? And to have that ability to, all right, I'm going to have to run the whole entire line today. It's going to take me all day to figure out what that problem is, where you can pinpoint it. Oh, it's coming from the customer's house. It's a return path issue. The customer's generating too much noise. And I can filter the house and then schedule a call and fix that home. And where we are today, you say, well, that's pretty future thinking, Steve. Now, we're already thinking about Wi-Fi proactive network maintenance, where the Wi-Fi network tells the cable operator, your customer's Wi-Fi is failing. You need to go out and fix it. You need to manage it. And wouldn't that be nice? You get a phone call from your cable operator. Hey, by the way, we noticed that your Wi-Fi, the performance is degrading. We have performance degradation. Really? Yeah, it's been running a lot slower. Well, we noticed that too, and we would like to schedule a call to help you fix it. Wouldn't that be nice? Or we could do a couple things here to improve it for you. Hey, we have a brand new access point. We can ship it out to you, do a self-install, or we can stop by and install it for you. Yeah, everybody likes selling new products, right? So this is the thinking, and even into MOCA as well, the Multimedia Over Coax Alliance, we're thinking about that as well. How do we improve that network in the home? But the ability to have visuals on your network where things are going bad, and then report back to your network. And I'll give you one I didn't even include called Node Health. Operators have created tools, and there's tools available, but to give you node health. So we score our nodes. When I was at Comcast, we scored all our nodes. This node's a 90, this node's a 70, this node's a 40, and then we had a report that came out every month. And guess what? If you were a supervisor and your node was on that report, somebody's calling you. So you did everything in your power all week long to make sure you didn't show up on that report. Because we called it the top 10 worst nodes report. And then there was owners. Everybody had an owner. Like, oh, this is Jacob. He owns this node. Jacob, what's going on? Why is your node at 70%? Well, how are you able to tell that, Steve? Because we can look at the modems, and we can look at the EMTAs that provide voice. We can look at how many of them are online. We can actually see the devices off the node. And if a bunch of them are offline, we take that data, correlate it with some other data, and we give it a score. So these are things to look at. What do my nodes look like? What does my network look like? But being more proactive instead of reactive is going to be the key for our networks. Of course, customer service comes with that too, right? And then this is the big one here is, how do I take my network to the next level? Do I just run a whole entire PON network? Sure, you can run PON to every customer. When will you realize that money back? How long will it take you to get that money back, right? So when some of the telcos did this, they were spending $1,800 to $1,700 a customer to put them on PON. Now today the cost is much cheaper to do that, but is that really the best way? So what we did, we looked at our networks. We did node splits. Anybody know what a node split is? Anybody? So a node is where we take optical signals from our provider and convert them to coax, right? Because to replace all the coax with fiber is very, very expensive with construction. So that's the conversion point between optics and coax, and that added a huge reliability. The challenge we had after that was we had too many customers on the node. So we had nodes that had 1,000 customers on them. So think about 1,000 customers trying to use internet, 1,000 customers trying to use the upstream. The quality was low. So what we did is we added an extra node, put 500 and 500. And that raised the quality. Then we took that node, 250, 250, 125, 125. Brings up the quality. It's less customers. Because in the return path of our networks, noise is generated from customers. So I rather see 125 customers affected than 1,000 because of one home. So that's the first step we did. And that was many years back. We're talking 15 years ago. That we were splitting nodes, and we did that for year after year after year until we can get it down to something manageable. Say 125, 200, whatever makes sense, 250. Once we did that, that improved the reliability. And then the other thing was, how do we remove the number of amplifiers? Amplifiers add noise to your network. More amplifiers, the more noise. If anybody has worked with audio, you know the more times you regenerate audio or the more times you amplify audio, if you keep it over and over, you're going to get noise, right? And that's what's happening in our network. So we had to figure out a way, how do we reduce the number of active devices in the network? How do we reduce the number of amplifiers? And with bandwidth, the way it's going is, how do we get to more bandwidth in our network is if you have less amplifiers, the next upgrade is much easier. Because if you want to go from an 860 megahertz network or a 750 megahertz network to a 1000 megahertz network, you have to replace all the internal parts of the amplifier. So if you have less amplifiers, it's a little bit more digestible. If you have no amplifiers, it's easy. It's like, this is great. I don't have to worry about that. So our evolution is HFC node splits, then it's fiber deep. All we're doing with fiber deep is pushing nodes deeper into the access network. We're adding more nodes. By doing that, we don't have any amplifiers after them. But we're still leveraging the last mile of coax. And we save on construction costs. We provide the reliability. We provide the capacity. And we're not held to 1,000 megahertz. We can go out, DOCSIS allows us to go out to 1.7 gigahertz or 1,700 megahertz. So we have flexibility there. And we can open up our upstream as well. And we don't have to do this throughout the entire network. We can say pockets of networks, we can go deeper and deeper and deeper. But the point is we can still leverage our HFC. We could leave HFC over here, leave that alone. And over here we have a lot of businesses, fiber deep. And there's another option. Scratch all of that evolution and just put a whole new network in, right? Let's run fiber optics all the way to the customer. You can do that, but fiber deep. Since your optical node is so deep in the network, the new nodes, you could pop out, you can open up the node, and you can actually pop in XPON modules, and you can do fiber to the home, fiber to the business, right out of a fiber deep network. It's already ready to go. So it's an evolution to get you there. You don't have to replace everything. So I'm just trying to share options. There's a technology called radio frequency over glass that we deployed. It allows you, so one of the challenges, if you go to XPON, GPON, or EPON, what happens to all the equipment in the home? Got to replace it. What about my set-top box? Oh, it's different now. What about my modem? Well, I got to buy all new modems. It's different. But what if there's a way to utilize everything in the home the way it is, but also build fiber all the way to the customer? It's called RFOG, radio frequency over glass. You can run fiber all the way to the customer, to this RFOG unit, radio frequency over glass unit, converts it to coax, and you can still use your set-top box, still use your cable modem, and any other equipment you invested in. All right, Steve, but I want to do GPON next year. No problem. RFOG has a pass-through port. You come along, click with a fiber jumper, GPON. EPON, whatever you want to do. So there's, again, incremental steps. And that's what I want to offer you here. The other technologies, future thinking, is distributed access architectures. It's called virtualization. I'll talk more about that, but we're actually taking the physical components of our cable modem termination system and moving them into the access network. We're also going to take the layer above that and move that into the network. And now there's talk about virtual CMTSs. Why? Save on cooling, heating, space. So that's really forward. But that's where it's going, virtualization. So that kind of gives you my idea there. And then there's some fiber optic deep designs. Just to show you, there's some fiber deeps. We call it a mother node. It works with amplifiers called erbium doped fiber amplifiers. So you can get 40 kilometers out of it if you need to. But it's an evolutionary step. So then when you get to the end there, you have your fiber deep node that sits here. And in that fiber deep node, run your coax like you normally would. And when you're ready, fiber to the home. So fiber to the X, I kind of shared that. It's wherever you go, I just kind of put one thing there, but all the big operators are doing fiber to the X because in pockets of your network that aren't built out, or for larger businesses, it makes sense, right? So I'm not saying all fiber deep. I'm not saying all HFC. I'm saying you need a mix. You're going to need some fiber to the home and fiber to the X for your businesses, so especially whether you choose GPON, which EPON is pretty heavily populated, but there's still a GPON, EPON mix. But that's what this is. And you can offer all your video, voice, and data over that. I would suggest RFOG because it gives you another step. Utilize all the equipment you invested in, and when you're ready, you can turn on folks into GPON or EPON as needed. We're talking 100 gig options for Ethernet PON. Ethernet PON is probably the most popular lately just because it's Ethernet. But GPON is also a way to do the technology as well. So I kind of mentioned the RFOG. I won't go into detail there, but I gave you the highlights. But actually, SET developed the standard for this, and it's actually a gateway to Ethernet PONs or GPONs. This is what it looks like on the side of the house. It's not very big. It's a plastic box. Okay, your network interface device, and inside is the RFOG ONU, Optical Network Unit, and you plug fiber into it, and on the other side is coax. The customer powers it, so we save on powering, and you can still utilize all your set-top boxes and everything in the home. You just got to learn a little bit about fiber cleaning and fiber maintenance, but it's a real nice design. So it kind of gives you some ideas. And now this is the RFOG pass-through port, but here's your options for your GPON stuff. If you want to do GPON or EPON, it's a separate device. So that's an investment by the operator. If you're going to do GPON, you need GPON devices. If I want to do RFOG, I can still use my cable modem that I'm using now. So it gives you flexibility. So this is over EPON. We call it Optical Distribution Network. That's the name for the HFC is hybrid fiber coax. There's fiber deep, and this is Optical Distribution Network, or what we call PON network. I had this in here. Did anybody know that gentleman there on the right-hand side? I actually told you at the top, but I actually met Peter Schultz. He is one of the 3 inventors of fiber optics from Corning. And I went over to him. I don't know if people didn't know who he was, and I went over and I said, Peter Schultz? Yes. I said, you're an inventor of fiber optics. I'd like to shake your hand. And, oh, thank you. And I started talking about him in the lab when he came across fiber. His story is very, very interesting, and there's actually a video I'll dig up that you can see his story. But the fact he's still around, and he never knew that fiber optics would be as big as it is today. And he actually had scraps in his coat that we went through some designs and things that he's like, yeah, look, I brought some pictures, and really interesting guy. But he never thought that we would be here talking about fiber to the X, fiber deep, and all these fiber, right? This is a GPON example. One of the challenges with GPON is not backward compatible. So if you want to move to different versions of GPON, you won't be compatible with the previous version. That doesn't happen with EPON. Just something to consider. And this is just an overview of GPON. Most operators are doing this version. It's all an ITU standard. The Ethernet is IEEE standard, and RFOG is SETE standard. So it's 3 different groups there. But you can kind of see the wavelengths. These are different frequencies that we use for fiber to the X. The nice thing about this, you can run all of these services. You can run GPON, EPON, and RFOG in your network all at the same time. And you can do HFC. So there's flexibility that way. So I'll stop there for a discussion on access networks. Okay.
Question. We in Jamaica, we have started doing some fiber to the home work. And to my knowledge, we are mainly doing GPON. Mm-hmm. We were of the opinion that EPON was more, the European chosen, while the American chosen was GPON. We also noticed that the GPON provides, approximately 2.5 and 1.25 upstream, downstream, downstream, upstream, respectively, while the EPON was more a 1.2 gigahertz, gigabit. So we somewhat moved towards that. Do you have a preference? We find that the GPON...
I'm vendor neutral.
Well, it sounded to me a moment ago that you are probably leaning towards Ethernet. And that's why I asked the question.
Yeah, I mean, the only Ethernet is very ubiquitous. We do a lot of carrier Ethernet. We do a lot of Ethernet in the home. Just Ethernet protocol is very ubiquitous. That's the only reason, personally, that I would kind of lean towards that. It's a very ubiquitous protocol. It's been around for quite some time. But really, GPON or EPON are both viable solutions. And you're correct that you'll get a little more capacity out of the GPON today. But I think EPON is going to overtake that in the long run when you start thinking about 10 gig or 100 gig EPON solutions. You say, well, why would I ever think of that? And that's if you're going after really large businesses. So that's, it really depends on your business plan and where you want to be. For us, we have to go after really large businesses that are nationwide. So whether it's banking, whether it's, retail, but that's the only reason.
We are also using the RF over glass. We just call it a mini node.
Yeah, that micro node. Yeah, mini node. Yeah.
A micro node. And we have the desktop version that you just plug into the customer house.
Yeah.
And with the EDFA, you bring them the RF to the existing set-top box. So we are already doing
That's
those
excellent.
things. Yeah,
That's excellent.
Yeah. Okay.
Thank you. Good time for one more question? Nobody? Come on. So like I mentioned earlier, broadband library is a good way to get yourself up to speed on all these different technologies. What I find is just having the knowledge, especially if you're a decision maker, what are all my options? There's a lot of options, right? And like you said, there's what's being chosen. Really, the big operators have sit back and said, look, we're going fiber deep. So big operators like Rogers in Canada, and big operator, while you'll see like Cox go out and do GPON, but they're now thinking of doing some EPON. But this is all stuff that's in the news, right? So keep that with an open mind that, it's really what's best for your business. We're not saying that one over the other, but all right. I'll continue. Get you out of here by 5. It's a lot of information, right? Okay. So you think, wow, okay, what about the future of cable? And you say, wasn't that the future, Steve? You just showed us the future? Well, there's actually beyond this.